3 earthquakes, 1 fault, less than an hour apart. And y'all, when I pulled up the USGS feed this morning and saw a magnitude 4, followed by a 4, 0, followed by a 3.9, all stacked right on top of each other along the same stretch of the Bartlett Springs Fault north of Covelo, California, I knew immediately this was the video I needed to make today, because this isn't the first time this exact fault has rattled this summer, and I don't think it's going to be the last. It is Tuesday, August the 11th, and let's get right into what actually happened, because I want y'all to have the real sequence of events before I explain why it matters. Earlier this week, a cluster of 3 earthquakes struck in rapid succession along the Bartlett Springs Fault, a few miles north of the small community of Covelo, up in Mendocino County. The strongest of the 3 came in at magnitude 4 with a 4, 0 and a 3, 9 and following close behind, all centered in essentially the same spot. All shallow, all in that 6 to 7 mile depth range that lets shaking reach the surface efficiently, rather than getting absorbed and dampened by miles of rock in between. Residents in and around Round Valley felt every single one of them, and USGS Did You Feel It reports came in describing light to moderate shaking, some rattled dishes, a few reports of things falling off shelves, but thankfully nothing in the way of serious structural damage based on what we know right now. Here's why this particular triplet has my attention, y'all, and it's not really about the size of these individual quakes, because on their own, a 4, a 4, 0, and a 3 Mach 9 are not enormous earthquakes by California standards. It's about the pattern building up underneath them. This isn't an isolated event. Back on June the 24th, a magnitude 5, 6 struck near Redwood Valley, not far to the southwest of where this week's activity is centered. On July the 3rd, a 3. 9 hit near Alder Springs, northeast of Covelo. And then just about a week after that, on July the 10th and 11th, this same general area saw another cluster, a 4, and a 4. 2 among them, all again centered just a handful of miles north of Covelo. So what we're looking at, when you zoom out and put all of this together, is a fault system that has produced a genuinely elevated level of seismic activity across a roughly 7-week stretch, culminating in this week's triple quake. That's the trend that has scientists paying closer attention, not any single earthquake in isolation. Let me explain what the Bartlett Springs Fault actually is, because I guarantee most of y'all outside of Northern California have never heard of it before today. And that's honestly by design, because this fault doesn't get anywhere close to the attention that the San Andreas gets. Even though geologists consider it a legitimately significant part of the same broader system, the Bartlett Springs Fault is a right lateral strike-slip fault, meaning the ground on either side of the fault line slides horizontally past each other, similar in basic mechanism to how the San Andreas itself moves, just on a smaller scale. It runs for roughly 100 miles through the coast ranges of Northern California, and it's actually considered the easternmost fault within the broader Northern San Andreas Fault system, part of a wide zone of parallel and sub-parallel faults that together accommodate the sliding motion between the Pacific Plate and the North American Plate. Compared to the San Andreas itself, which creeps along at roughly 2 inches of movement per year in some sections, the Bartlett Springs Fault moves much more slowly, generally estimated at around 1/4 of an inch per year. But slow movement doesn't mean small potential, and this is the part I really want y'all to understand. Geologists have determined the Bartlett Springs Fault is capable of producing an earthquake up to magnitude 7, 0. I want to sit with that number for a second, because I think it's easy to hear magnitude 7 and not fully appreciate what that actually means compared to the 4s we just saw this week. Let me give y'all a real point of comparison from this same fault's own history, because it helps ground all of this in something concrete rather than just abstract numbers. Back in August of 2016, this exact fault produced a magnitude 5. 1 earthquake centered in a remote stretch of the Mendocino National Forest, not far from Lake Pillsbury, and at the time it was described by seismologists as the strongest quake along the Bartlett Springs Fault in more than 50 years. That 2016 quake was felt across a genuinely wide area from Point Arena on the coast all the way east to Chico and Oroville out in the Sierra foothills, and it happened along a fault that, at the time, most Californians outside the immediate region had never even heard of, the same way most of y'all watching this probably hadn't heard of Bartlett Springs before today. I bring that up because it shows this fault is capable of producing felt, newsworthy earthquakes well above the magnitude 4 range we saw this week, even without approaching anything close to its theoretical magnitude, 7 maximum. And it's a useful reminder that quiet for decades and incapable of a significant quake are 2 very different things for a fault like this one. The earthquake magnitude scale is logarithmic, meaning each whole number increase represents roughly 10 times the ground movement and around 32 times more energy released. So the jump from a magnitude 4 to a magnitude 7 isn't 3 times worse. It's on the order of tens of thousands of times more powerful in terms of energy release. A magnitude 7 earthquake along this fault, given its proximity to communities across Lake County, Mendocino County, and stretching toward the edges of the Sacramento Valley, and even the northern San Francisco Bay region, would be a genuinely serious, damaging event. Not the light shaking and rattled dishes we saw reported this week. Now, I want to be really careful and really clear with y'all here, because I think this is exactly the point in a video like this where fear-mongering creeps in on other channels, and I refuse to do that to y'all. A cluster of magnitude 3 and 4 earthquakes does not mean a magnitude 7 is imminent. Earthquake swarms like this one happen along active faults with some regularity, and the vast, overwhelming majority of them never lead to anything larger. In fact, when USGS scientists ran the aftershock forecast following this week's largest quake, the odds they calculated for something in the magnitude 5 range or higher within the following week came out under 1%, and the odds of anything approaching magnitude 6 or 7 were even smaller than that. So the statistical reality here is that another moderate earthquake, or even nothing further at all, is by far the most likely outcome. What I want y'all to take from this video isn't panic, it's awareness, because a fault capable of producing a magnitude 7 earthquake putting on this kind of show over a 7-week stretch is exactly the kind of situation that deserves genuine attention, even while the statistics stay reassuring in the short term. Let's talk about why a swarm like this happens in the first place, because I think understanding the mechanism helps take some of the mystery and honestly some of the fear out of a story like this. Along a strike-slip fault like Bartlett Springs, stress builds up gradually over years and decades as the two sides of the fault try to slide past each other but get locked in place by friction. When that accumulated stress finally exceeds the friction holding a particular section of the fault together, it releases in a sudden slip, which is what we experience as an earthquake. Sometimes that stress release happens as one clean, isolated event. Other times, releasing stress in one spot on the fault actually transfers additional stress onto a neighboring segment, which can trigger a secondary quake nearby within seconds, hours, or days, producing exactly the kind of clustered sequence we saw this week. 3 earthquakes, essentially back to back, in almost the same location. Scientists refer to earthquakes like this as a swarm when you get a cluster without one dominant, clearly largest main shock followed by a typical aftershock decay pattern. And what's happened across the Bartlett Springs Fault this summer looks like it has elements of both a swarm and a more traditional main shock aftershock sequence, which is part of why seismologists studying this fault are watching it with real interest right now. I also want to touch on the Makima Fault because it runs parallel to Bartlett Springs, a bit further to the west, and it's part of the same broader conversation happening among seismologists studying this region right now. The Makima Fault is also considered capable of producing a major earthquake in the magnitude 7 range. And back in June, before this whole sequence on Bartlett Springs even got going, a magnitude 5. 6 struck near Redwood Valley in that same general corridor. Then just this past week, a separate magnitude 4. 5 struck out near Island Mountain in Trinity County, a bit further north. None of these individual events are necessarily directly connected in a mechanical sense. These are still technically separate faults. But the broader Northern Coast Ranges region has clearly had an unusually busy several weeks of seismic activity across multiple fault systems simultaneously, and that regional pattern is exactly why this week's triple quake made headlines beyond just the local Mendocino County news outlets that would normally be the only ones covering a magnitude 4 swarm like this. Let's talk about what this actually means for the people living in the affected area, because that's ultimately what matters most here. If you're in or around Covelo, Round Valley, Redwood Valley, or anywhere else across Mendocino and Lake County that's felt this activity over the past several weeks, I want to give you all the same kind of practical guidance I'd give anybody dealing with any active hazard on this channel. First, make sure your household actually has an earthquake plan, and I mean a real one, not just a vague sense that you'd figure it out. That means knowing the drop, cover, and hold on technique, dropping to the ground, taking cover under sturdy furniture, and holding on until shaking stops, rather than trying to run outside during active shaking, since most earthquake injuries happen from falling objects and debris inside a structure, not from the building itself collapsing in a moderate quake. Second, this is a good time to do a basic home safety check, securing top-heavy furniture like bookshelves and water heaters to wall studs, and making sure heavy items aren't stored on high shelves where they could fall during shaking. Third, put together or refresh an emergency kit with water, non-perishable food, a flashlight, a battery-powered or hand crank radio, and any needed medications. Because in a larger earthquake scenario, you may be dealing with power outages, water system disruptions, or blocked roads for an extended period afterward. I know this channel is built around severe thunderstorms, tornadoes, and tropical systems, and earthquakes are obviously a completely different beast. No forecast lead time, no watch or warning issued hours or days in advance, just sudden shaking with zero notice. But I think that's actually exactly why a story like this deserves coverage here, because the total absence of lead time with an earthquake makes having your plan and your supplies already in place before anything happens even more critical than it is with a hurricane or a tornado where you at least get some warning. If you live anywhere in earthquake country, and that's a huge stretch of the western US, not just California, treating your earthquake kit and plan with the same seriousness I ask y'all to treat a hurricane kit with is genuinely one of the most important things you can do, precisely because you will not get advance notice the way you would with the weather hazards we normally talk about here. I also want to mention briefly that seismologists do continue to research whether certain patterns of earthquake activity can serve as meaningful short-term indicators of a larger event to come. But I want to be straightforward with y'all that reliable earthquake prediction, in the sense of confidently forecasting the specific time, location, and magnitude of a future quake, remains something scientists have not been able to achieve, unlike the kind of forecasting we do every single day on this channel for tropical systems and severe weather. What seismologists can do is calculate probabilities, like that under 1% chance of a larger quake within the following week that I mentioned earlier, and continue monitoring fault behavior for anything that departs meaningfully from the historical pattern. That's genuinely useful information, but it's fundamentally different from a forecast track cone I'd show y'all for an approaching hurricane, and I think it's important to be honest about that difference, rather than overstating how much certainty this kind of monitoring can actually provide. I do want to mention one piece of technology that genuinely does help close part of that lead time gap, and that's Shake Alert, the earthquake early warning system that now covers California, Oregon, and Washington. Shake Alert doesn't predict earthquakes before they happen. It detects the very first, less damaging waves an earthquake produces, called P waves, which travel faster than the more damaging S waves and surface waves that cause the actual shaking and destruction people feel. By detecting that initial P wave and rapidly calculating the earthquake's location and likely magnitude, the system can, in some cases, deliver a few seconds to as much as a minute or more of warning to areas farther from the epicenter before the strongest shaking actually arrives, depending on how far away you are from where the quake originated. That's not a lot of time, but a few seconds is genuinely enough to drop and take cover, for a surgeon to step back from a patient, for a train to begin automatically slowing down, or for industrial equipment to shut down safely. It's available for free through the MyShake app, as well as built directly into wireless emergency alerts on most modern smartphones in the covered states. If y'all live anywhere in California, Oregon, or Washington, and you don't already have that set up, I genuinely encourage you to check that your phone has wireless emergency alerts enabled, because unlike our severe weather coverage, where I'm asking y'all to set up y'all call days in advance of a storm, this is a system that's already built to work automatically. You just need to make sure it's not turned off. I also want to touch briefly on secondary hazards that come along with earthquakes in this specific part of California, because the Coast Range's terrain surrounding the Bartlett Springs Fault adds an extra layer of risk beyond just the shaking itself. This is steep, rugged, heavily forested terrain, and earthquake shaking in mountainous regions like this can trigger landslides and rock slides, particularly on slopes that are already saturated from recent rain, or that have been destabilized by wildfire in prior years, since burned hillsides lose the root systems that normally help hold soil in place. If a larger earthquake were to strike this region, road closures from landslide debris could genuinely complicate access to some of the more remote communities scattered through Mendocino and Lake County, which is part of why having supplies on hand to be self-sufficient for at least several days matters even more in a rural mountainous area like this than it might in a dense urban environment with more redundant infrastructure and faster emergency response times. So here's where I want to leave y'all today. This week's triple quake along the Bartlett Springs Fault is part of a real, documented uptick in seismic activity across a broader stretch of Northern California's coast ranges over the past several weeks, involving multiple faults capable of producing a major magnitude 7 earthquake. The statistical odds still strongly favor this settling back down without anything larger following, but the pattern is genuinely worth watching, and if you live anywhere in the affected region, this is exactly the kind of moment to make sure your earthquake plan and your emergency kit are actually ready, rather than something you've been meaning to get around to. I'm going to keep an eye on this fault activity alongside our usual severe weather and tropical coverage, and I'll update y'all if anything meaningfully changes with this sequence. Subscribe to this channel and hit that bell, and if you've got family or friends anywhere in Mendocino or Lake County, go ahead and share this with them, because a lot of people outside that immediate area have no idea this fault even exists, let alone that it's had this active of a summer. Stay prepared, stay aware, and I'll see y'all in the next one. I love y'all.